Okay, our final lesson here for this school year, Unit 11, Objective 3, we are looking at power rule. It's the first derivative rule that you will learn, and you will build on it next year in both AB and BC. There are quite a few other derivative rules, but all of those other derivative rules, or I should say most of those other derivative rules, do end up tying back in some way, shape, or form to power rule. And specifically the derivative power rule. There's also an integral power rule that you will learn. But this derivative power rule that we're looking at today is the first kind of faster way that you will learn to take a derivative. In Objective 2, you looked at the definition of a derivative. Reminder that the derivative of f at x is given by this limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And you practiced walking through this process. It's a vital one to know. You'll hear us say this again next year, but there are problems on the AP test for AP Calculus that will look like this. And ultimately, our goal really is to not have to go through that long process that we learned originally last semester and then reviewed in Objective 2. Our goal ultimately is to be able to look at this kind of thing and go, oh, that's a derivative. That's the definition of a derivative, to be able to see that, to be able to locate our f of x at the back, and then to be able to do what we're going to learn today, which is to do the derivative process faster, right? We don't want to have to walk through that longer process. Okay, so some common notation for derivatives. F prime of x is how we notate that we've taken a derivative, right? F prime of x. We use this one, I'd say, primarily when we are given a function already in terms of f of x, g of x, h of x, that kind of thing. Then we do f prime, g prime, h prime. There's dy over dx or y prime. Both of these are used, I'd say, primarily when you are working with a function that is given in terms of y. Personally, I like dy dx more than y prime, only because while I know y prime is faster to write, y prime, I've seen students mix up y prime here with y to the first power. And those are two different ideas. Y to the first power is not the same thing as y prime. Y to the first power is 1y, right? Y prime is the derivative of y, right? So personally, I use dy dx more than I use y prime. I'll use f prime of x, though, if f is given, right? Okay, and then we have some other kind of vocab concept ideas here. So differentiability. A function is not differentiable at x equals c if it is discontinuous, right? So we looked at in Objective 1, we reminded ourselves of what a removable discontinuity is and a non-removable discontinuity is, and next year you'll build on this some more. Look at ideas where, or what it means to be discontinuous. Okay, a function is also not differentiable if it has a sharp turn. This is also called a cusp. It looks like this, and again, you'll build on this some more next year, right? So if it has a sharp turn or a cusp, or has vertical tangent lines, which again, I know I'm going to keep saying this, but we're introducing these ideas so we've talked about them before, so there's at least a little bit of a foundation so that when you come into it next year, you might be going, oh, I remember hearing that word cusp before, as we look at kind of how that impacts the problems that we will continue to learn to solve in calculus. Okay? Power rule, though, which is our focus for today, this idea here, power rule says that if n is a rational number, so n is 2, 1/2, right? Rational meaning it can be written as a fraction. It's like 2 could be 2 over 1. 0.5 could be 1 over 2, so 0.5 is also a rational number. But pi is not a rational number, right? Pi is irrational. It can't be written as a fraction. So if n is a rational number, then the function f of x equals x to the n, so this could be x squared. This could be root x, which is x to the 1/2, right? Is differentiable, okay? And the derivative of x to the n, so x squared, is in, which is that number that was in my exponent, brought down in front of my function, x, which is the x that was originally there, and then the exponent becomes, rather than the n it originally was, it becomes n minus 1. Okay, this here is your power rule. It's how we are going to speed up the derivative process that we learned in Objective 2, is if we can look at a function and see it in this form, x to the n, then we can take the derivative by, again, bringing that exponent down in front. The n comes down in front, becomes a coefficient. The x stays x, and my exponent becomes whatever that original n was, becomes n minus 1. And we're going to model this quite a few times as we walk through this. And then we're also going to be looking at plugging in numbers. Now, a couple of additional pieces to kind of build on before we get into practicing this, things that pertain to our power rule. And so I'm going to do this in blue here. Your power rule has to be in this form. So, if you were looking at something like 1 over x squared, you couldn't yet apply power rule. Notice this is x to the n, not 1 over x to the n. The x needs to be up in the numerator. And so quick little kind of exponent reminder here so that we can eventually apply power rule. We are able to rewrite 1 over x squared. How do you rewrite 1 over x squared so that it's just x to the something? Okay, well this would be x to the negative 2. Right? That's an exponent rule. Negative exponents move things from the numerator to the denominator and vice versa. Okay, and so you're going to have to use that today. A couple of other algebraic reminders pertaining to our power rule. Coefficients take a variety of forms. 3x squared, we obviously very quickly see the coefficient there. This is 3 times x squared, right? But the one that's sneakier is this one, x squared over 2. That one also has a coefficient. Right? What is its coefficient? If we were to rewrite it like we did here, 3 times x squared, what is being multiplied to my x squared there? Okay, well what's being multiplied by x squared is 1/2, right? And so that's a little bit of a sneakier coefficient. Okay, and then the final thing with our power rule here is while addition and subtraction work just fine, so I can take the derivative, there's actually a rule called the addition-subtraction rule. I can take the derivative of two functions being added or subtracted together. Right, so this is take the derivative of f of x either plus or minus g of x. And I can just treat them individually. I can take the derivative of f, and then I can take the derivative of g and just add or subtract them together. And that's fine. However, anything that is being multiplied or divided or an extra exponent implying some sort of maybe FOIL idea or something like that, nothing with multiplication, division, or an extra exponent is allowed if you are using power rule. Okay? Next year you're going to learn other rules that help you navigate multiplication, division, that kind of thing. They're called product rule for multiplication, quotient rule for division, chain rule for an extra exponent. For this year, because we are going to focus in on trying to secure our power rule understanding, we are instead going to use algebraic properties to undo that multiplication, division, or extra exponent. So multiplication, we're going to FOIL it out. Division, a reminder with division, we reviewed this last unit, or 2 units ago. I don't remember if it was last unit or 2 units ago, but with division, we can very quickly undo this by splitting the fraction, right? Because they have a common denominator. And so we can rewrite it like this, and this will allow us to eventually use power rule. And with extra exponents, we again are going to use some sort of expansion, distribution, FOIL, however it is you prefer to view it as. But we need to get it into a form where we can see our x to the -2, or our x squared, or our x to the 1/2. We're going to initially rewrite our function to see all of those individual pieces. Okay? One final thing here related to our power rule before we get into practicing this is that there is a derivative rule. Some people view it as its own rule. Others see it as a manifestation of the power rule, which is the derivative of a constant. Okay, so no exponent attached. So this is not 5x, this is just 5. Okay, the derivative of a constant is 0. And there are a couple of different ways you can remember this. First up would be remembering what a derivative is. Remember that a derivative is the slope of your tangent line. Well, imagine a function of, say, y equals 5. Picture that for a second. What does y equals 5 look like? Okay, y equals 5 is a horizontal line. Right? That's not very flat. There we go. Y equals 5 is a horizontal line. Okay, what is the slope of a horizontal line? Okay, the slope of a horizontal line is 0. And so if you're taking the derivative of a constant, aka finding the slope of a horizontal line, that's a derivative again is slope, constant would be a horizontal line, right? Y equals 5 is a horizontal line. Okay, if you're finding the slope of a horizontal line, that slope would be 0. And so some people see it in kind of a conceptual way like that. Others see it in a little bit more of an algebraic way, which I will briefly walk through as we continue through our problems here, just in case you kind of prefer that a little bit more of an algebraic way of remembering why a derivative of a constant is 0. Okay? Okay, so getting into kind of modeling what we are looking at here, taking our derivative, we have quite a few examples here, the idea being that you want to try to get this to be as fast as possible. The first couple that I walk through, I'm going to go pretty slow through it because, again, they're the first couple we've looked at, but ideally speaking, you want to start being able to figure out how to speed up this process. I always liken it to in elementary school when you did math facts. I think those are still a thing. I know they were when I went through elementary school and you had to do those like timed math facts. You had to get 100 addition right in so much time, right? And a lot of people got pretty quick at that. We want to have a similar mentality with our power rule to the point that we can look at x cubed and go the derivative of x cubed is 3x squared. And again, you will get to that point. If that's not this year, it will be next year. I promise. People get really fast with power rule because you do so much of it. And so I know it looks like there's quite a few examples, but it's because we're trying to kind of get that speed up, right? Practice it to the point that maybe we don't have to go quite as slow through all of our problems, okay? Okay, so I'm going to do 2 together, and then after we do 2, my recommendation is to pause the video on number 3. Try number 3 on your own, restart the video, maybe fast forward to the answer if you're pretty sure you did it right and you can just check your answer. Or if you need to hear the explanation, you can walk through the explanation of number 3. Pause the video also for number 4. Try number 4 on your own. If you after number 2 you feel like you still need to listen to number 3, go ahead and do so, but make sure to pause the video on number 4. Try it on your own at some point. Because then 5, 6, 7, 8, 9, and 10 all build on what we are establishing in examples 1 through 4. So make sure that you don't wait too long before you start to pause the video and try it on your own. Like I said, 1 through 4 are kind of our foundational examples. 5 through 10 build on that. Okay? So 1 and 2 I'm going to walk through here. Okay, number 1, we are looking at y equals x to the 5th plus x squared minus 4x. Okay, so we're going to go ahead and take our derivative, which again, I always use dy dx myself rather than y prime for the reasons I explained earlier. Okay, so the first thing you want to do as you're looking at this is to make sure that you are looking at bits and pieces that are in this form, x to the n form. right? We want to see an x, we want to see its exponent. If we see a coefficient out front, that's okay. We can still see what our x to the exponent was. Even if the coefficient looks like this, that's okay. We can pull it out. Pluses and minuses, remember, are just fine, but we would need to rewrite anything that somehow disguised your exponent. So that could be x squared like that. That could also be, I had meant to write this, sorry. Could be something like cube root of x. What is cube root of x again? X to the what? It's like 1/3. And so my recommendation, especially here at the beginning, as you're starting to still get the hang of power rule, is to take a moment and rewrite anything that is in any way disguising your x to its exponent. Okay? X to the 5th has nothing with it, so I'm just going to leave that one alone. I'm good to go, right? X squared, good to go. That -4 might initially be a little bit tricky for some people, so if you need to, then rewrite it like this, right? 3x squared is 3 times x squared. So 4x is 4 times x. And then the only other thing I'm going to add in here is I can see my x and my in x to the 5th, right? X and n is my 5. X and x squared, n is 2. What is the in x? Okay, the n is 1, right? And again, you might get to the point where you stop having to write that 1, and that's totally fine. For some people, you might write that 1 for all of the rest of this year, and that might not be something you stop writing until next year. But for now, we're going to write it just to make sure we can see exactly what our x and our n are as we apply our power rule. Okay? And so then power rule states that if I can see my x to my n, so let's do this on the x to the 5th, then I can bring my n down in front. Well, my n on x to the 5th was 5. Right, so I'm going to write n equals 5 here. So I'm going to bring that 5 down to the front. Right, there's my n. My x is still going to stay. And my exponent now, rather than being n, is going to be n minus 1. And so my exponent for this one, rather than being 5, is going to be 5 minus 1, which is 5x to the 4th. Okay? And then we're going to repeat that process for each of them. Okay, now this second one, my n is 2. By the way, you also don't have to write the n equals 5 and the n equals 2 up top. If you can do that in your head, that's fine. Okay, but that we're going to write n equals 2 here. Okay, that n comes down in front. Right? So the n comes down in front. The x stays the same. And rather than my exponent being n, my exponent becomes n minus 1. Okay? Which is 2x to the 1, which is just 2x. Okay? And then back here, my n is 1. Okay, so we're going to bring that n down in front. So that 1's going to come down in front. The x is going to stay there, right? X still stays x. And my exponent becomes my n, my 1, minus 1. Okay, which is 4 times 1 is 1. And this is x to the 0, which x to the 0 is 1. Still be 4 times 1, so we have minus 4 there. Okay, and if you didn't believe that this would work, you could walk through that long process that you learned in Objective 2 on this guy. And you would get 5x to the 4th plus 2x minus 4. Okay? Okay, number 2. We have y equals x to the 2/3 minus 3. Taking its derivative. Okay? We have our x to the n that we can clearly see in that first one. Okay? The second one, we can't quite see our x to the n, and so this is where you would have a choice to make. Okay? One, you can look at this and you can go, oh, that's a constant. And I know that the derivative of a constant, aka the slope of a horizontal line, is 0. And so you can go, I'm not going to worry about that anyway, it's going to be 0, and call it good, and you can just focus on the x to the 2/3. Or, as I mentioned earlier when I walked through this, some people prefer a little bit more of an algebraic idea behind why the derivative of a constant is 0. And so I'm going to very quickly model that just in case you kind of prefer this, this route, although I will explain really quickly why you have to be careful with it. This 3 here does have an x behind it, right? It's an x to the 0, right? Because think about that. What is x to the 0 again? X to the 0 is 1. And 3 times 1 is 3. So constants do have an x component to it. They have an x to the 0. Okay? Well, imagine for a second, if we were to apply our power rule on x to the 0, what would your n be? Your n is 0, right? I'll write that here. N equals 0. Well, imagine bringing that 0 down in front. What are you now doing when you bring that 0 down in front? Well, you're multiplying by a 0, right? What is anything times 0? 0, right? So that 3 would be going away simply because, besides the fact that it's a horizontal line and the slope of a horizontal line is 0, that 3 would be going away because when I bring down the n in applying power rule, I end up multiplying by 0, and so that 3 is going to go away anyway. It's being multiplied by 0. So that's a little bit more of an algebraic way of thinking about the fact that if you see a constant out back, you know that its derivative is going to be 0. It's going to go away anyway. Okay, so 2 different ways of thinking through that. Okay, so applying our power rule to this x to the 2/3, I can see my n is 2/3. Okay, so I'm bringing the n down in front, 2/3, the x is staying, and my exponent is going to become the n minus 1, 2/3 minus 1, which is 2/3 times x to the 2/3 minus 1, which is negative 1/3. Okay? Okay, so if you want to watch one more, go ahead and do so, and then maybe pause the video and try number 4. If you feel like you're maybe starting to get the hang of it, you could pause the video now and try number 3, but again, make sure that you at least try number 4 on your own. Only difference for those who are wanting to pause their video now between number 3 and say number 1, for example, or number 2, is that you have a root here. Well, we walked through earlier a reminder of how to rewrite a root. You will have to do that step on number 3. So heads up, if you're planning to pause the video now and try number 3 on your own, you will have to rewrite that root. Okay? Okay, so walking through number 3 here, we have derivative of f, so f prime of x. By the way, I always get some students who ask, does it matter whether we use f prime or dy dx? Technically, no. These 2 different notations come from our 2 different fathers of calculus, Leibniz and Newton. And so they are used interchangeably. You need to be comfortable using either one and comfortable seeing either one and recognizing that they mean a derivative. So technically, no. Although, as I said earlier, typically speaking, if we are given f of x, we use f prime. It's a little funny to be given f of x and then to use dy dx, right? We use dy dx more when we're given y. Right? Kind of like switching languages to go from f of x to dy dx. So we're going to keep in the same language. F of x becomes f prime. Okay? So derivative. Let's go ahead and see our power rule here. So I'm going to rewrite these so I can see my n. So what would be the n, the exponent on this x? Well, that would be 1/4. Plus, and then this one, what would be the exponent on this x? Be 3/4. And maybe if you haven't paused the video, maybe now's when you want to pause the video and walk through the power rule now, see if you can at least do the power rule piece, right? But walking through that, we have, okay, my n here is 1/4. So I'm going to bring that n down in front, right? So the 1/4 comes down in front, and my exponent becomes that n minus 1. Okay? Which is 5/4 x 1/4 minus 1 is negative 3/4. Okay. The back here, my n is 3/4, so that n comes down in front. My exponent becomes 3/4 minus 1, which 3/4 minus 1 is -1/4. Okay? Okay, if you haven't already, now's the time to pause on number 4. Try that power rule on your own. Okay, so I'm going to steal a little bit of space for our rewrite here because I used some for my notes off to the side. X cubed, 4x squared. What is this x's exponent? 1/2. And then we have our plus 3 at the back, which remember, depending on how you think of it, you could think of it as 3x to the 0, if you prefer that. You could think of it as that's a horizontal line, so its slope is going to be 0 anyway. That 3 is going to go away regardless. So depending on how you prefer to think of it. Okay. So my derivative is, here, my n is 3, so that n comes down in front. X stays, my exponent becomes 3 minus 1, n minus 1 for your exponent, right? 3 minus 1. Okay, here my n comes down in front, and my exponent becomes n minus 1. Okay, here my n is 1/2, so that 1/2 comes down in front, and then n minus 1. And then back here, the derivative of 3 again is going to be 0 one more time, either because you go, oh, that's a constant, therefore a horizontal line, and a slope of a horizontal line is 0. Or because you're thinking, okay, bring down the n in front, right? The n comes down in front. Well, when that 0 comes down in front, I'm multiplying that entire term by 0, and so that entire term is going to be 0. It's going to go away. So regardless of how you think of it, nothing happens with that 3. It just disappears. Okay? And so then this is 3x squared plus 8x to the first, it's just x, minus 1/2 x to the -1/2. Okay, for the rest of these notes, we are going to be building on this power rule idea, looking at places where we might have to get rid of the multiplication of two functions like I talked about earlier. Next year you'll learn product rule, which is our other workaround, but for now we're going to FOIL stuff or distribute, that kind of thing, so like what you see in 5 and 6. As well as some division components and making sure we're comfortable with rewriting things as negative exponents, potentially splitting fractions, that kind of idea. And so each of these pairs of problems have been structured so that we can do one just kind of to review the algebraic piece, maybe walk through another power rule together, but then so you can pause the video and try the second one on your own. So for example, you'd walk through 5 with me, unless you wanted to pause the video and try it on your own, you could, but you'd theoretically walk through 5 with me, and then pause the video and try number 6 on your own, because 6 models a lot of the same stuff that number 5 does. Same with 7 and 8, 9 and 10. Okay, so with number 5, we have here something that is very close to power rule. Unfortunately, because we have our two functions here being multiplied, we do need to do a foiling, expansion, distributing these things, right? And so we'd be doing 3x times x, which is 3x squared, right? 3x times 4 is 12x, minus 5x, which is 7x. And remember, what is the exponent on x? 1, right? And then negative 5 times 4 is negative 20, which is that same idea we've talked about a couple of times now with the constant. You can either know that that 20 is going to go away because it's a constant, or you can write your x to the 0 at the back as a reminder that when you bring the 0 down in front, that back term is going to go away. Okay? And so then applying your power rule, okay, you have your 3, my in here is 2, right? X to the in for applying power rule. My in here is 2. So that in is coming down in front. And then this becomes 2 minus 1. Okay, here my x is, or my in is 1. So that 1 comes down in front. Becomes 1 minus 1. And back here that's going to be 0. Okay. And so this is 3 times 2 is 6, x to the first, plus 7 times 1, which is 7, x to the 0, which is also 1. 7 times 1 is still 7. Okay, we've got another one for you to practice, kind of that same process. Only difference here is you do have the squared, so instead of seeing your two quantities side by side, you will need to make sure you recognize that this is 3 minus x squared times 3 minus x squared, right? But go ahead and pause the video, try number 6 on your own, restart it when you are ready. Okay. Okay, so foiling this out, we have 3 times 3, which is 9, which you can go, that's a constant, it's going to go away, or you can write your x to the 0 next to it if you'd like. Okay. 3 times negative x squared is negative 3x squared, minus another 3x squared, which is negative 6x squared. And negative x squared times negative x squared is x to the 4th. Okay. So then taking your derivative, you would have, this is going to be 0, right? Then we have our in is 2, bringing that 2 down in front, subtracting 1 from the exponent. Then our in is 4, bringing the 4 down in front, subtracting 1 from the exponent. Which gives us our answer. Okay, number 7. So same thing with 7 and 8. 7 is for us to walk through together. 8 is so you can do one on your own. 7 and 8 have this idea of having to rewrite your denominator as a negative exponent, right? So walking through number 7. Can't leave it as x cubed, so how are we going to rewrite that? It's going to be x to the negative 3. We have our 4/3 here, but we can't leave that as x squared, so how are we going to rewrite that one? Okay, well, that's going to be x to the negative 2. And what about that x at the back? Okay, well, that's going to be x to the negative 1. Okay, so now that we have it in our power rule form, we're going to go ahead and apply power rule. Okay, what is the in the first term? Negative 3, so we're going to go ahead and bring that negative 3 down in front, and then your new exponent is going to be in minus 1. Okay, in the second term is negative 2. Bring that negative 2 down in front, and your new exponent becomes in minus 1. And then the back we have an in of negative 1, so bring that negative 1 down in front. Your exponent is in minus 1. Okay, which simplifies to negative 9 x to the negative 4 minus 8/3 x to the negative 3 and plus 5x to the negative 2. Okay. Okay, go ahead and pause the video, give number 8 a shot, restart it when you are ready. Okay, number 8, distributing here, we're going to have 3 root x. Well, how can I rewrite that x with its exponent? Okay, that would be 1/2. Distributing the 3 again, we have minus 3. How do I rewrite this x? x to the negative 1 plus 3x to the first. Thankfully, I don't have to rewrite. Oh, I forgot to distribute, though. Plus 9 x to the first. Right, 3 times 3 is 9. But thankfully, I don't have to rewrite the x at all. It's already in power rule form. Okay? And so now we can apply our power rule. Okay, what is the n in the first term? That is 1/2, so we're going to bring that 1/2 down in front. And our exponent is 1/2 minus 1. Okay, what about the second term? N is negative 1. And then new exponent, negative 1 minus 1. And in the third term, n is 1. The exponent is 1 minus 1. Which gives me 3/2. X to the 1/2 minus 1 is negative 1/2. Plus 3, x to the negative 1 minus 1 is negative 2. And then plus 9 times 1 times 1, which is 9. Okay? Okay, and then one last pair here before we look at some more application similar to what we did in Objective 2. Okay, numbers 9 and 10. Number 9 is so you can walk through it with me. Number 10 is so that you can pause the video and try number 10 on your own. Okay? So number 9, we have our 2x over x minus x cubed over x. And I say it that way because, again, one more time like we reviewed in our prior unit, and then at the beginning of these notes, we can split a fraction to get rid of the division, right? So we're going to do that. It's going to be 2x over x minus x cubed over x. And next year, as I mentioned earlier, you will learn another derivative rule where you don't have to walk through this process. It's called Quotient Rule. But it's good to have this process in your back pocket. Sometimes the quotient rule isn't friendly. And so you might want to split the fraction like we're going to practice today, so you don't have to do quotient rule. Other times you might just choose to do quotient rule. Okay? And again, you'll learn that next year. Okay, so we have our 2x over x minus x cubed over x. We've split our fraction here, which allows us to rewrite this. 2x over x is just x. X cubed over x is x squared. And these are now in power rule form already. If you wanted to, you could also rewrite this as 2x to the 0 minus x squared, if you like that idea of writing it as x to the 0. Again, it's just personal preference. Okay, and so then applying our power rule. That constant, our 2, is going to end up becoming 0, right? And then we have our minus x squared. Our n is 2. That 2 is going to come down in front. And my exponent is going to become n minus 1. So this is just negative 2x to the first. Okay? Go ahead and pause the video, give number 10 a shot, restart it when you are ready. Okay, rewriting this, we have our 5x over x cubed minus 2 over x cubed, which allows me to get rid of this division. This becomes 5 over x squared minus 2 over x cubed, which is 5x to the negative 2 minus 2x to the negative 3. And we can do power rule. Okay? So on that first term, we have dy dx equals, my n is negative 2, so the negative 2 is going to come down in front, and my exponent is going to become negative 2 minus 1. Okay, in the second term, my n is negative 3, so that negative 3 is going to come down in front. My exponent is going to become negative 3 minus 1. Okay. So this is negative 10, x to the negative 3, plus 6, x to the negative 4. Okay? Okay, so that is power rule. You're going to continue to practice it in the last 4 examples that we have. But kind of summing it all up again one more time, and as always, if there are questions or you want extra practice of anything, please email us. We're more than happy to answer that. But summing it all up, for power rule, you do have to get it into this form, x to the n. So 1 over x squared does not work, right? X plus 1 over x squared does not work. 2 functions being multiplied, like number 5 or number 6, does not work. You have to manipulate those functions, FOIL things out, rewrite stuff as negative exponents, divide, so that you can get it into your power rule form, x to some exponent n. Okay? Okay. So then the last 4 examples here, numbers 11, 12, 13, and 14, build on what you already looked at back in Objective 2, which is a reminder of what exactly a derivative is. And then we are going to practice that using our power rule instead of what we did before. So like with the last ones we just did, these are structured so that you can do one with me, one on your own. Okay? A reminder that the definition of a derivative, okay, is that limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And what a derivative is the slope of your tangent line, right? And so in numbers 11 and 12 here, what they're asking you to do is almost exactly what we were just doing in 1 through 10. When you see this instruction, take the derivative, that is synonymous with find the slope of the tangent line. This means take the derivative. The only difference between 11 and 12 and 1 through 10 is that in 11 and 12, you're going to be given a value to plug in. That's literally the only difference. When you read find the slope of the line tangent, your brain needs to say take derivative. When you read take the derivative, your brain needs to say find the slope of the line tangent. They are synonymous, right? Okay, so number 11. Walking through number 11 together, it says find the slope of the line tangent. My brain says take derivative. I even wrote it. And it says at x equals -1. So I'm going to go, okay, I'm going to plug that in at the end. Okay? So let's go ahead and first off take the derivative. Well, we have a little issue here. That's not yet in power rule form right there. So how can I get that 1 over x squared into power rule form? Its exponent would be -2. And so now I can take my derivative. F prime of x is, the n in this first term is 2. And then my exponent is going to become n minus 1. In the second term, my n is -2. And so my exponent is going to become -2 minus 1. Okay? Which is 3 times 2 is 6. X to the 2 minus 1 is just 1, so 6x. Minus 2, and then this is x to the -3. And then because I'm going to be plugging a number in here, if you're comfortable plugging your number into x to the -3, go ahead and do that. But for me, I always like rewriting that so I can see my x cubed that's in my denominator. Okay? Again, that's personal preference. Okay, so then I'm going to plug in my -1. Now to show the person looking at your work that you have plugged in -1, instead of writing f prime of x, we're going to write f prime of -1. That's telling your grader or whoever is looking at your work that I'm taking -1 and I'm plugging it in everywhere my x is, right? And so then I'm going to plug my -1 next to the x. My -1 is going to get cubed in the denominator, which is -6 minus 2 divided by -1, which is -2. So this is going to be minus -2 or plus 2, which is -4. Okay, so that's it. like I said, 11, 12, exactly the same as 1 through 10, just you're going to plug in a number at the end. That's it. Okay, so go ahead and pause the video. Give number 2 a shot. Restart it when you're ready. Okay. Number 12, we're thankfully already in power rule form, so let's go ahead and take its derivative. My n here is 2/3, so I'm bringing that 2/3 down in front. My exponent becomes 2/3 minus 1. And then what's the derivative of a constant again? Well, that's 0. So I'm already done with my derivative. My derivative is 2/3 x to the negative 1/3. Which again, we're going to have to plug 27 in, so if you're comfortable plugging it in there, great. I'm going to go ahead and rewrite this so I can see this is a cube root, 1/3, in the denominator because of that negative. So I'm going to rewrite it like that. Okay? And then plugging in 27, so we're going to write g prime of 27 is 2/3 times the cube root of 27. Well, the cube root of 27 is 3, and so this is 2/9. Okay? And then last but not least, find the slope function for each of the following. Write the equation for the tangent lines. Okay, so writing the equations for the tangent line, you're going to hear this reiterated over and over and over and over again next year because it is a very common AP question. It shows up both as multiple choice and free response. And so while this year you might still be looking at your notes for clarification of that instruction, and that's okay, right? That is totally fine if you're looking at your notes for clarification of that instruction. By the end of next year, when you're taking the AP test, you will have heard that instruction many, many, many times, to the point that ideally, when you read that instruction, your brain goes, write the equation of the line tangent, y minus y1 equals m times x minus x1. This is our point slope form. It's how we will write our equations of the line tangent because it's the fastest way to get your points on the AP test. Okay, and so we're going to be practicing it already now today. And again, if on your homework you're looking at your notes, I promise it's okay. If this feels a little rough, you're going to do it a lot next year, right? Okay, so write the equation at the x value specified in each problem. Okay, so when you're doing problems like this, again, we're going to do number 13 together. 14 is so you can try it on your own. Okay, the first thing you want to find are a starting x and a starting y value. Okay, well, the nice thing about these problems is they've already given us a starting x value. Our starting x value is 1. And so I'm going to go ahead and plug that in. There's my x1. Question is, well, what's my y? When x is 1, what does y equal? Okay, well, you know how to figure this out. Think about that for a second. If I'm given an x value and I have an equation, how do I get the y value for that given x value? Okay, well, we plug it in. You take that 1, plug it into your y. And so I'm going to plug my 1 into my y here. 1 cubed minus 3 times 1 squared plus 7. And so what does y equal? Y equals 1 minus 3 plus 7, which is negative 2 plus 7, or 5. Okay, well then we need the slope. Remember, slope of the tangent line is the derivative. It's what we were doing up here. That slope is the exact same thing we've done in numbers 1 through 12. Right? We're going to be taking the derivative and we're going to be plugging a number in. Right? And so go ahead and take a moment. Let's take the derivative. I've used dy dx a lot. Let's use y prime. Again, this is why I don't like y prime, but I do want to model it at least once. I don't like y prime because it looks a lot like y to the first power. Right? Let's go ahead and do y prime. Okay, so we're already in power rule form, thank goodness. Okay, so my n in this x cubed is 3, so I'm going to bring that n down in front. And my exponent is going to become n minus 1. Okay, then we have n of 2, so that n is going to come down in front. My exponent is going to be n minus 1. Back here we have a constant, right? X to the 0. So that 7's going away. So my derivative is 3x squared minus 6x. My slope then, at x equals 1, so let me go ahead and show that I'm plugging in 1, is 3 times 1 squared minus 6 times 1, which is 3 minus 6, or negative 3. And you're done. Okay, that's what a derivative is. It's the slope of a tangent line. Okay? Okay, go ahead and pause the video. Try number 14 on your own. Restart it when you're ready. Okay, number 14. We're going to go ahead and set up our equation here. We already have an x. Yay. So part of my answer is done already. Okay, what is my y when x equals 4? Okay, my y is y of 4. My y is root 4 minus 4 plus 3 times 4 squared, which is 2 minus 4 plus 16 times 3, or 48, which is negative 2 plus 48, or 46. Okay? And then your slope, okay, well, let me go ahead and rewrite this so I can see my power rule. Y equals x to the 1/2 minus x to the first plus 3x squared. Okay, so taking the derivative, my n in the first term is 1/2, so that n comes down in front. Your new exponent is n minus 1. Okay, second term, your n comes down in front. And your exponent becomes 1 minus 1. And last term, your n is 2. That 2 comes down in front. Your exponent becomes 2 minus 1. Okay? Which is 1/2 x to the negative 1/2 minus 1 times x to the 0, which is 1, plus 6 x to the first. And again, we're going to be plugging 4 in, so if you're comfortable plugging it in there, great. I'm going to rewrite that root x that I've got here in my denominator, and then I'm going to plug in myself. Again, it's personal preference. You don't have to rewrite if you're comfortable plugging in with the negative exponents. Okay? And so then plugging in 4, 1 over 2 root 4 minus 1 plus 6 times 4, which is 1 over 2 times 2 minus 1 plus 24, which is 1/4, or 0.25, whichever one you prefer. And then negative 1 plus 24 is 23. And so my slope is 23.25. Okay? Okay, so as I mentioned earlier, you are going to do a ton of this next year in both A, B, and BC. So this is just to start laying the foundation. If it still feels a little rough, I promise you it's fine. You're going to get a good handle on power rule next year. But the stronger you can get it this year, the easier it's then going to be next year as we build on this, as we continue to grow in our derivative rules with product rule, quotient rule, chain rule, etc. Okay, so as always, if there are questions, let us know, but that is Unit 11, Objective 3.